All right, so again, my name is Matt Varner. I'm the Alaska Aquatic Resources Program Leader for the BLM. And today I'm going to talk a little bit about an assessment, inventory, and monitoring program that the Bureau implemented some time ago. It's something that I'm pretty passionate about, and I think it might have some value to the partnership moving forward. I'm going to try to keep this within the 15-minute time frame. It's probably going to run over. Fortunately, we get a pretty big Q&A time block, so I think there'll be more than enough time to answer questions as well. But just basic outline, I'm going to cover why we're implementing aquatic AIM, or just a standardized assessment program across the Bureau. Give a little bit of the history of the program, as well as the flexibility that's built in. Talk about how data can be accessed both internally within the organization, but then also by the public, and then highlight a couple examples of management applications. So just starting off, why are we doing aquatic AIM? And AIM is an acronym. It stands for Assessment, Inventory, and Monitoring Program. It all started back in the early 2000s. BLM was asked by the Office of Management and Budget, or OMB, what the conditions of the public lands were. And despite spending tremendous amounts of funding annually for inventory and monitoring, the BLM was unable to really describe the condition or trend of the resources, or speak to the effectiveness of management actions, except in localized areas. So in 2011, the AIM strategy was developed. And the goal of that strategy was collecting data that can yield scalable results, speak to the effectiveness of management actions, and inform adaptive management moving forward. So pretty lofty goal, but it made a lot of sense considering that the BLM is the nation's largest landlord. For the BLM in Alaska, the goals of the AIM strategy made a lot of sense. I mean, we have the BLM manages some huge landscapes in Alaska, and across those lands are tremendous aquatic resources. And this is just a snapshot of what the habitats that we manage in Alaska. And you can see we manage much of what exists nationwide on BLM lands when you think about streams and rivers. Fortunately, most of the BLM managed lands in Alaska are unaltered. But with that, we recognize the importance that we have to establish a baseline so that we can understand the degree and the magnitude to which they may be changing, especially based on climate. The benefits of habitat information, or the value, I think are pretty well known by this group in particular. But oftentimes, I think the needs are and the work is focused at a very local scale, or reach scale, where you have a specific project or a specific question. A drawback of a reach-based or localized study is that you lack that understanding of how those local conditions compare to the surrounding region. So you often end up having to rely on interpretation of those results by contrasting it with professional judgment or peer-reviewed publications from areas around or potentially outside of the region you're working in. For us, one of the key goals of the AIM program was just the idea that we want scalable data. We want to be able to collect the data once and use it to answer multiple questions. So those questions included being able to address local questions, like related to permitted activities, for example, but also being able to address regional questions related to regional conditions and trends. So trying to pull data across ecoregions, or what we commonly refer to as management planning areas, which are large blocks of areas where we set specific objectives for management. And then even talking about cross-ownership stuff, cross-agency, where, as we all know, our BLM lands and Forest Service lands and state lands are just all intermingled with other land use owners as well. So fortunately, there's not major differences across those boundaries, and using similar assessment methods gives us the power to begin to roll data up across the state, Bureau-wide as well. And that is really the important, one of the key aspects of AIM, is this idea of scalability. the four fundamentals of the AIM strategy are shown here. And for aquatic AIM, and I should say that the AIM umbrella, this idea of assessment, inventory, and monitoring for the Bureau, isn't limited to aquatic resources. It also covers terrestrial resources and riparian wetland resources. So there's several different standardized methodologies that kind of fall under this AIM umbrella. And I'm going to focus on the aquatic side, obviously. But for aquatic AIM, these four fundamentals, related to these four fundamentals, we focused on really three of them. We're still sorting out how to integrate remote sensing technologies into our assessment approach. But we've certainly rallied around the idea of quantitative core indicators, statistically valid sample designs, and electronic data capture. Like I said, most of my focus is going to be on the aquatic side, and even more focused on the wadable stream side. We have kind of two different approaches. We have an assessment methodology that focuses on wadable streams, and you can think of that as streams that are less than an order of 4, stream order of 4, versus boatable, and that would be streams that are 5th order and greater. But with that said, we are starting to implement boatable methods, and this summer on Beaver Creek Wild and Scenic River, we're going to be implementing a boatable. I think one of the first, it's the first for BLM. DEC has implemented boatable assessments that are really analogous to AIM, and I'll talk about that later quite a bit in the state in several areas, the Yukon and other large river systems. The other thing I want to note is that you might see on these slides and if you even dig into some of the documents that I referenced, you'll see references to the National Aquatic Monitoring Framework, this NAMF. That's basically aquatic AIM. So hopefully I don't confuse folks when I use aquatic AIM, that you see this reference to the National Aquatic Monitoring Framework. They're the same. What you see here on this slide is the list of core measures that we use for AIM: pH, salinity, temperature, and these are single point in time collections. Pool dimensions, frequency, stream bed particle size, bank stability, cover, floodplain connectivity, large woody debris, macroinvertebrates, riparian vegetation, and canopy cover. Those are the core measures that we collect every time that we go out to a site that is part of the probabilistic sample design to establish reference conditions. We don't necessarily collect all of those core measures when we're doing targeted monitoring, trying to answer a specific management question. But I wanted to highlight some of these core measures that are kind of the central focus of the data collection that we do in the field.
Hey Matt.
Yeah.
Sorry to cut you off, but it looks
That's
like
okay.
some people are having trouble seeing the slides, so I didn't want us to get any further until we get sorted out.
Yeah, are you able to see them, Nick?
I can, yeah.
Okay.
So I'm kind of not sure I know a fix.
And it looks like Sue's having trouble. Anybody else?
Maybe it's a personal problem. I might jump off and jump back in and see if it fixes itself. Okay.
I'll just hold for a second. Any questions thus far while we're waiting to see if the slide situation improves?
Hey, I got one, Matt. Is pool frequency what I think it would be? Like how many pools in a certain amount of distance?
Yeah, so the reach length is dictated by the bank full width. And then what we do is we assess the qualifying pools within that reach. And then based on the bank full width, you can calculate things like pool to pool spacing. So it becomes, you can use it in terms of a dimensionless ratio calculation. So you can compare streams that may be of different sizes together.
Got it. Looks like Sue can see it now, so I think we're
Awesome.
good.
Awesome. Great. Okay, so with that, I want to open the door to the flexibility that AIM affords. We have a list of contingent methods that can be collected at a site if they're applicable or if they're needed to address a specific management question, but they're not required. We also, at any time, have the ability to add supplemental methods. For example, in the National Petroleum Reserve, we collected eDNA samples while we were collecting AIM data, and that was used to develop some fish distribution models as part of a NASA grant to Utah State University. So there's a lot of, anytime you have management questions that go beyond the scope of basic habitat assessment, you have the ability to add those supplemental measures to the data you're collecting. Probably what I'm most excited about with AIM, besides just the scalability component, is this electronic data capture aspect. As we all know, we're all very comfortable collecting data in our field notebooks, but that requires data entry when you're back at the office and all the things that go with that, and you get into issues transcribing data, etc. AIM is built on electronic data capture. So you take your iPad to the field, you're using Survey 123 forms, you have QA/QC built into the field-based data collection, where if you enter a value that seems like it's an odd value, it'll be flagged, and it'll ask you if that's truly right. And then in addition, we have QA/QC processes in the office where you review annotated photos, you look at initially computed indicator values to determine do these values make sense based on what you're seeing. So it's the process in and of itself is very streamlined. And then probably even more important is the fact that the data are easily accessible. For the BLM, we can access both the summarized data as well as the raw data. If we're interested in specific transects at a reach, we can see that, we can access it. The public now also has that same benefit of being able to access the data from our national data portal. For me, one of the big benefits too is we have national support on workflow development, troubleshooting. We have a whole series of YouTube videos that walk you through the various data collection components. So we really minimize the hiccups that come, and we're able to get people really up to speed quickly on how to collect data and how to access the data and how to use the data to support decision making. In Alaska, we're also building some Shiny apps to expedite the ability of users to quickly visualize their data. So for example, if you have data across a particular region, you can look at the distribution of values for a specific metric of interest. And then if you have targeted data, say you went out to a site that was impacted, and pick your land use practice that maybe is causing the problem, you assess it, you can compare those values from that site quickly using a Shiny app against those regional reference conditions. And so we're trying to build tools like that so that staff and users can quickly look at the data and see to what degree do we have a difference at this particular site in a region. The last thing I'll mention is we're working on a multi-metric index for macros with our National Aquatic Monitoring Center at Utah State University. And it's really focused on interior for now, but we're beginning to pull enough data across other regions that we feel like we're positioning ourselves to develop MMIs for other areas of the state as we move forward. I hinted at this earlier, but the BLM's aquatic AIM study design and methods are essentially the same as those used by the EPA as part of their National Rivers and Stream Assessment Program, or NRSA. NRSA, and Dan's probably really familiar with this, but NRSA collects a few more water quality parameters than AIM, but by and large the methods are the same. The study design is the same, and likewise, because EPA provides money to DEC in Alaska, DEC's AK MAP program is 100% based on EPA's National Rivers and Streams Assessment Protocol. So what that means is that DEC data and BLM data can be integrated together and used, and we have done that. DEC and the BLM jointly collected data in the NPRA, and we're able to roll those data up together. And we also combine field trainings annually now as part of BLM's AIM program. to further solidify some of this data use we're working on. I am working on a partnership with DEC and MOU to really formalize that data sharing and efforts across the state to address habitat assessment data gaps. For folks that are interested in data access, and I think many of you probably are, you can navigate to the BLM data portal. The web address is here. It's this first link. And you can pull data for any region of interest, and you'll see data not only when you open this up. What you'll quickly realize is it's focused on the lower 48, but all you have to do is pan up to Alaska, and you'll see all these points populate, and you can grab specific points. You can highlight certain regions of interest, etc. So it's very accessible. The BLM also routinely summarizes data in what we call open file reports. And they're available through ARLIS as well as on the web. For example, our Eastern Interior area was summarized in an open file report. And we also summarized the data that we jointly collected with DEC for the National Petroleum Reserve, at least the Arctic Coastal Plain portion of the NPRA. It's available. And we're currently working up data for the Glen Allen Field Office, which is kind of that southeast corner. Not southeast in the sense of Juneau, but I think you get what I'm getting at. East of southeast, I guess or east of south central, I should say. And it's in progress. And then we're going to have a report developed for our Bering Sea Western Interior region coming up probably later this winter. So we really try to get our information summarized and integrate examples of how that information can be used by managers so that people understand the utility of the data and aren't struggling with how to apply it to questions they might have in a particular area or region. And so I added the links here you can see for AK Map, our open file reports, and our AIM data portal. And so hopefully folks can make use of those. And if you do have questions, you can certainly reach out to me later. Digging into specific examples, you can see here, this is our Eastern Interior Field Office. That's its boundary and where it's located in the state. We developed a study design that was focused on 2 regions of interest, and it was just these 2 discrete areas where we had large blocks of BLM land. There was the 40 Mile and then the Steese National Conservation Area, White Mountains area. And AIM is based on what's called a generalized random tessellation stratified survey design, or GRITS. And that's the same design that EPA uses for NERSA as well as DEC for the AK MAP program. And it's a probability-based approach that and I'm not a statistician here. Some of you may be more adept at explaining this, but it contrasts a bit with like a simple random design, which tends to clump sites, and or like a systematic sample, which I think are a little bit more difficult to implement for aquatic resources. So what it does is it weights, at least for aquatics, we weight the sample based on the occurrence of streams on the landscape based on stream order. So obviously first order streams are the most common and prevalent on the landscape, so we tend to have more sites on first order, and then after that it's second order and third order, and we have the fewest sites on like fourth order streams for our weightable sample design. And so it really closely mimics that spatial density pattern of the resource, and I think it provides a lot of benefits because most of our uses are on those smaller streams anyway, at least on BLM lands. The outcome then is a design that can be used to describe regional conditions, develop benchmarks, and use those benchmarks to assess the effectiveness of what we authorize on the landscape, at least from a BLM perspective. In this box plot, what you see is just an example, and it shows the distribution of values from reference data across the region for a specific metric, and in this case, it's bank cover and stability. And what you see from that is that the central tendency of the data tends to show that sites, reference sites, are generally greater than 65% bank cover, bank stability. And that's pretty important because it gives us an idea of what should the minimum be for management? When we have an impact, what should those reclamation or restoration goals be? And in general, what we want to see are sites that are within that central tendency of reference condition. But certainly if you had high value aquatic resources, you may want to set benchmark values much higher than what we tend to use in the BLM. Moving forward to how you might use it for targeted sampling, like say you wanted to assess the effectiveness of reclamation, and you go out and you look at a mine site and they're preparing to do reclamation, or perhaps they've completed reclamation, and you collect targeted aim data and you plot it against this reference data set, and wow, what you find is this, what I'm showing here at this red star is, wow, you're a major departure from reference condition and way outside of what our goal is. And so then what you can do is you can identify that goal, and in this case, work with that operator to implement additional reclamation measures to create that functional lift. And this is just one measure, and we use a variety of metrics from AIM specifically to inform placer mining. But showing kind of a real world example here, this upper image on the left is a site prior to mining. The image on the lower left is that same location after mining. And you can see there's a big difference there. And that is not the outcome that we'd like to see post reclamation. And so based on AIM data, we were able to implement corrective actions at this site and required significantly more work to be done, which otherwise might have been difficult because we get into a kind of a tug of war oftentimes about what constitutes stability or reclamation and rehabilitation of habitats. And AIM data gives us really an unbiased look at what is the range of conditions that we see in unimpacted sites, and use that as really the goalpost for operators. And in a way, it becomes a little bit more difficult for people to argue because it's not arbitrary. It's not based on professional judgment. It has some relevance to the region that you're working in. Going a step farther here and stepping back to this regional level, we, like I mentioned before, we commonly summarize data in these open file reports. And when you get into those, you'll see a lot of these box plots. And we tend to tease out some that are very relevant to the land uses that we authorize on BLM lands, like channel incision or riparian vegetation complexity. Those are some of the ones, or bank cover, bank stability. And so just looking at this example, what you see here is that on the left side, you have a box plot for our Eastern Interior Field Office, and it's focused in on channel incision. And channel stability in general is heavily reliant on a stream being connected to its floodplain. So when it's disconnected from the floodplain, it's incised. And so channel incision or floodplain connectivity are measures of incision. And on this left side, what you see is data from our Eastern Interior Field Office showing box plots that describe reference condition as well as conditions from a variety of mine sites within that field office that have been reclaimed. And so the takeaway is that the mine sites tended to have a moderate to major departure from reference conditions. So in other words, they tended to be incised and disconnected from their floodplain. The box plot on the right is from our Central Yukon office, which you can think of the Dalton Corridor area. And similar measure, slightly different computation. Floodplain connectivity is a little bit easier for people to understand than the measure channel incision. So we've kind of shifted to using floodplain connectivity more, but it's the same concept. And here what we see is similar conditions, but conditions at mine sites in the Central Yukon area tended to be more incised, and so less connected to their floodplain. The takeaway here is that the mine sites tended to be far from what our reclamation goals had laid out. looking at another measure, riparian veg complexity, and this is about the extent of riparian vegetation and the structure of vegetation at a particular site. We see the same kind of layout here. The left side's from our Eastern Interior Field Office. The right side is from our Central Yukon Field Office. Both sets of box plots kind of tell the same story, where mine conditions tended to be a major departure from reference condition, and that's really not a surprise. Mine sites are, because of the nature, they're going to be pretty raw, less extent of vegetation, etc. But this is a way to show it visually and compare and contrast it against reference conditions. Transitioning to the Mat-Su, I think many of the same benefits that data derived from AIM or AK map provide to the BLM and to DEC are also of value to the partnership. Understanding condition and trend across the region is critical to making inferences at the local level, and being able to link those changes with corresponding changes in perhaps stream temperature or fish habitat use, distribution. All those things can help managers better understand how their actions can impact ecosystem functions. And then to wrap up, the BLM, AIM, EPA, NERSA, and DEC AK MAP program, those approaches all use the same statistical designs. As a result, they're scalable. They allow users to use the data in a variety of ways, whether it's answering local questions about specific conditions of a stream reach, all the way up to describing regional reference conditions. And then, and I didn't mention this before, trend is also a big component. So we use this GRITS design to go out and sample conditions across a particular region. And then after 10 years, we go back and resample 50 to 75% of those sites, in addition to new sites, to really assess how those habitats are changing over time. And we're going to start our first trend assessment in our Eastern Interior Field Office in 2024, and I'm super stoked to see what we find out there in relation to trend. So with that, open it up to questions. I just flagged the data portal again here and added my contact information.
Thanks, Matt. Folks have questions. I'll try to. Well, I'm echoing. Anyhow, I'll try to see hands up on people.
And I know that's a lot. That was a lot to digest. So if you do have questions afterward, feel free to reach out.
Laura.
Yeah, great presentation, Matt. Thank you so much. Just a quick question about your data. Have you considered using the National Water Quality Portal, or does your BLM site here that you have, does that feed into the National Water Quality Portal?
It doesn't, and I think I've heard some complaints about that portal, in fact, from your peers. The data that get uploaded into that portal, I think the usability of that information, being able to extract it and use it's a little bit cumbersome. We're actually thinking about exploring a way to kind of export data out of EPA's database and bring it into ours, just because the way our database is structured, it's a little bit more user-friendly.
Yeah, I would agree that the portal is really bad. I was just curious. Thank you.
Yep.
Dan.
Oh, sorry about that, man. I was having trouble finding out how to unmute myself. Hey, are you guys doing any of the biological protocols? And in particular, I'm curious if you're doing the the fish community protocol at these sites?
Yeah, so that would be the fish community stuff would be a supplemental indicator, and for the most part, we have not done any of that work. We focus primarily on macroinvertebrates at our sites. It's really a function of time, Dan, I think, more than anything.
Sure.
Yeah. The amount of time it takes to either spot shock or do any kind of fish sampling, it just becomes too much.
Yeah. You have a lot more diversity to work with on the invertebrate side too. So I think that might factor in.
Don't see any more hands. Anybody else have something for Matt?
Hey, I had a quick question. This is Jillian with Fish and Game. Matt, are there any stream? Sorry, I can put my hand back down. Are there any stream types? And I may have missed this in your presentation. Is this recommended for particular stream types or any stream types that you're still working on?
It's not limited by stream type. We are able to use the data to classify stream reaches based on the channel types that are present. But it's not limited, but you certainly need to be able to compare apples to apples. So when you roll it up, the last thing you want to do is compare like a braided glacial outwash plain to a mountain headwater stream and try to compare those things. So we definitely try to segregate the streams in a way so you can compare and contrast. Fortunately for the work that we're doing right now, we're focused very much on wadable streams. So with that in mind, we don't have too many wadable sites that fall into that braid plain type bucket. They're mostly single thread alluvial channels. So we haven't had too many issues yet, but that is when you begin to look at the data and roll it up, you definitely need to go site by site and assess. And we do this already. We look at each site to determine, is it truly reference? Are there impacts in the watershed? So we do a lot of imagery analysis looking at each site, but then the other aspects relate to what is the channel type present there so that you can compare data.
Michael's got his hand up.
Yeah, I have two questions. The first one is you showed a box plot where it was percent, I think, bank vegetation by stability, and I was just curious what your guys' measurements you use for stability. And then my second question was, I was just kind of curious on kind of the typical amount of effort kind of goes into collecting per given reach, I guess a typical reach, what kind of effort goes into collecting all this?
Yeah, so we average about 1.5 sites a day. So it's not an easy lift to do the reference reach work. But the flip side is when we do targeted data collection, where we actually have a management question, say it's a mine site, for example, and we want to go out and assess reclamation and then compare it against our regional data. We focus in on a small suite of measures. We go ahead and set up the entire reach, but we very much focus on about 10 different measures, and we can typically get a targeted site done in about an hour and a half. So it's a little bit more focused there, but that varies based on what your management questions are. And all of this, the whole AIM design process starts with what are your management questions within the region, and then your core methods are kind of set, but it really helps you shape what supplemental measures you might need, like fish community could be one, for example. But to get at your question about bank cover and stability, the document you want to reference it's a BLM tech reference 1735-2, but stability has to do with the bank angle, whether there's any type of fracture or break associated with it, and then the material that it's composed of. So is it covered in vegetation? Is it dominated by rock over a certain size? Is there any evidence of a fracture, a slump, a slough? Those types of things all factor into that bank stability rating.
It looks like Jessica's got her hand up.
Yeah, thank you. Matt, I think you covered this, but I just thinking about the National Fish Habitat Partnership does a national assessment of the status of fish habitat across the country. And so I was just thinking about the, potential use of utility of your aquatic aim framework for that. And so yeah, I guess that's part of the question, is that potential utility. And then part B of the question is currently, what are some of the other agencies and how far is it kind of in use across the country?
As far as use by other agencies, so it's kind of the BLM has its own, I mean, we call it AIM, but it's EPA has NRSA, and the different state and agencies they get funding, so they're implementing it as well at various scales. And so in Alaska in particular, we've been collaborating with DEC for a while, and we're certainly trying to get complete coverage of BLM lands, and by 2030 we will have complete coverage of all of the wadable streams on BLM lands across the state, and we'll be well in the trend monitoring phase. DEC is trying to close data gaps kind of in and around, but it's very focused. They spent a lot of time in Southeast, helped us in NPRA. They've done various things, and their program is much more multifaceted, I should say, because they're not only doing wadable, they're doing boatable, they're doing coastal lagoons, they do lakes, so it's pretty diverse. But probably something just to highlight too is that the Park Service is very interested in AIM, and BLM has an interagency agreement with Park Service, and we've been collecting data in the Kantishna Mining District for several years, and this year we're moving to Yukon Charlie. So helping to close some gaps in the federal family across the state too. We haven't cracked the Fish and Wildlife Service refuge nut yet, but I'm hoping to expand that partnership there eventually too. I think with some of the potential change over time, based on climate, I think having baseline sentinel sites on the landscape that we go back to every 10 years are going to be really informative. And certainly we're headed that way with BLM. It would be nice to bring the other agencies along, and we are. It's not as far along as maybe I'd hope, but we're making some progress there. As far as being able to roll up the data within the Mat-Su and tell a story, I certainly think AIM could do that. It could be based on a GRITS design for the partnership area, and systematically completed over a period of time based on funding and staff, and then you have something to use in the future, especially as it relates to trend monitoring, to say something about the conditions. Likewise, you'll have a reference data set to compare potential impact streams against, or if mitigation work is done in the Mat-Su to restore streams, you could use the AIM data to compare and contrast those restoration efforts and determine the degree of functional lift that was achieved.
Thank you.
Anybody else got any questions? I'm not seeing any, but Matt, just thank you. That was a in-depth, and congrats on a great tool that you've got going there. But a program, I should say.
Yeah, thanks for the opportunity to come chat about it. And like I said, if folks have questions later on, just feel free to reach out.
Great. Yeah, thanks, Matt. And as we said, we've recorded the talk, and we'll check in with you before we send it out to the partnership email list, which is, I think, almost 500 people. So we'll be circling back.
All right, great.
Great. Well, I've got it on the agenda to take a quick break, and we are at about 50 minutes or so right now. So why don't we take a quick one? Is that all right with everybody, or any objections to that? Let's say just 5 minutes. Be back here. Well, it's I'm seeing 3:23, so at 3:30, maybe come back, and I think we got maybe 30 more minutes or so to finish up at 4 o'clock, if that. Well, actually, well, not, I don't know, but that sounds, no one objects. See you back here at 3:30.